In this video, we are going to solve exercise 1B of D1 7th edition. And question number 1 from basic level is find the highest common factor of each of the following sets of numbers. So first part is A, that is you have to find HCF of 12 and 30. Now, if you have to find HCF of 12 and 30, do prime factorization of 12 as well as of 30. So 2 6 times 12, 2 3 times 6, 3 1 times 3. Similarly, prime factorization of 30 is 3 10 times 30, 2 5 times 10 and 5 1 times 5. Now you have to write down the factors of 12 and 30 in such a way that similar factors from 12 and 30 must be written in the same column. For example, 12 has got the factors 2 and 2 that will become 2 square while expressing it in index notation. So this 2 square is written over here. While now go to the factors of 30 and find that if there is any factor of 2 available. Yes, we have a factor 2 in the factors of 30 as well. So now write down this 2 under this 2 square. Now after writing the factors like the factors 2 of 12 as well as of 30, now move to the next one. From 12 we have got one of its factor as 3, so write down 3 over here. Now go to 30 and look if there is a factor 3. Yes, we have got a factor of 3 in the factors of 30, so write down it in the same column of 3. So this is the second column of the factors. Now the next one from factors of 30 is 5. So in factors of 30 write 5 over here. But if I will look into the factors of 12, I don't have a 5 in factors of 12. So because I don't have a 5 in factors of 12, I need to complete this column, and for that reason I have written here 5 raised to the power 0, because any number raised to the power 0 is basically equal to 1. So just to make this column complete, if any factor is missing, then enter it as power 0. Now I have written all the factors of 12 as well as of 30. Now when you have to find the HCF, then you have to go to each column, and from each column you have to take out the number that has the lower power. Mean we have 2 raised to the power 2 here, and we have 2 raised to the power 1 over here. So the lesser power is 2 raised to the power 1. So for HCF I have to take the lower power out, so 2 power 1 is taken out. Then move to the next column and observe the powers of 3 here as well as here. Now both powers are same, so 3 power 1 will be taken out. Move to the next column and take out the power which is lower one. Here we have got 5 power 1, here you have got 5 power 0. So 5 power 0 will be taken out over here because it is lower than 5 power 1. So this is the process of finding the HCF. Now multiply them. 2 into 3 is 6, and 5 power 0 is 1 basically. So 6 will be your HCF for this part. Now in part B, you have to find HCF of 84 and 156. So prime factorization of 84 is done over here, and prime factorization of 156 is over here. 242 times 84, 221 times 42, 37 times 21, 71 times 7, while 278 times 156, 239 times 78, 313 times 39, 13 1 times 13. Now write down the factors of 84 and 156 over here. The factors of 84 in index notation are, now starting from the factors first of all from 2 and 2 in factors of 84 will become 2 square. Now move on to factors of 156 and look for 2, because I am now I right now I am working on 2 factors equal as of 56. From that I have to take out 2. So 84 have got 2 2's, no, that is 2 square, while 156 have got again 2 2's. So write down the factors of 156, 2 and 2 as 2 square. Now move on to the next one in factors of 84, that is 3. In factors of 84, write down 3. Now move on to factors of 156 and look for 3. Yes, we have got 1 3 over here as well. So write down 3 in factors of 156, but this 3 should be written under this one, like this 2 square was written under this 2 square. Now move on in the factors of 84, we have got a 7. Write down 7 in factors of 84. Now move on to factors of 156 and look for 7. Do we have a 7 in factors of 156? No, we don't. Then write down 7 power 0 in factors of 156. In order to complete this column, I have entered 7 power 0, though there is no factor of 7 in 156. But let me explain. 7 power 0 is 1, so it will not affect this result. Now the next one, the factor 13, which is present in factor of 156. So in factor of 156, write down 13. However, 13 is absent in factors of 84. So in factors of 84, the factor which is absent but present in the factors of 156, so enter it as 13 power 0 in order to complete the column of 13. Now from each column, you have to choose the number with lower power. From here 2 power 2 and 2 power 2, I will obviously select 2 power 2 because the powers are same in both the cases. From 3 power 1 and 3 power 1, now they are equal, so take out 3 power 1. From 7 power 0 and 7 power 1, I have to choose the lower one, which is 7 power 0. This is for the HCF case. And then from 13 power 1 and 13 power 0, I have to choose 13 power 0, the lower one from this column, that is for the case of HCF. Now 2 square is 4, 3 power 1 is 3, 7 power 0 is 1, 13 power 0 is 1. So 4 into 3 will give you 12, which is answer for this part. In part number C of exercise 1B, D1, question number 1, 15, 60 and 75. Now you have to find the HCF of these three. Now follow the same process. Do prime factorization of 15, prime factorization of 60 and prime factorization of 75. Write down factors of 15. The 15 is 3 and 5. Now first of all work on the factor 3. Write down 3 from factors of 15. Now look for the same factor 3 in factor of 60. Yes, we have got 1 3. So write down under this 3 the factor of 60 over here. Then look for 3 in factor of 75. Yes, we have got a 3. So write down this 3 in factor of 75, but in the same column where you are writing 3. Now go to 15 from the start and write down the next factor of 15, which is 5. So this 5 is written in the factors of 15. Now look for 5 in factor of 60. We have got a 5. So write down this 5 in factor of 60 and go to 75 and look for 5 in factor of 75. We have got 2 5s. Now that will become 5 square. Now the next one is the factors of 15 are no more. In factor of 60, we have got 2 and 2 mean 2 square. So in factor of 60, write 2 square. But we don't have a factor of 2 in factor of 15. So if you don't have a factor, then write it as 2 power 0. Similarly, we don't have got 2 in factor of 75. So instead of leaving an empty space over here, write down it as 2 power 0 just to make the column of 2 complete. Now from each column take out the number having the lowest power. From column of 3 take out 3 power 1 because we have got 3 power 1, 3 power 1, 3 power 1, so the powers are same. So So take out 3 power 1. From factors of 5, the lower power is 5 power 1. So take out 5 power 1 from this column as common, and from this column 2 power 0 is the lower one among all these. So 2 power 0 will be taken out because we are finding HCF, and in case of HCF you have to take out the lower powers while expressing the factors in index notation. Now 3 into 5 is 15 because 2 power 0 is 1. So 3 into 5, 15 will be the answer. Now question number 1, exercise 1b part D. You have to find HCF of 77, 91 and 143. So prime factorization of 77 is 11 7 times 77, 7 1 times 7. Prime factorization of 91, 7 13 times 91, 13 1 times 13. And prime factorization of 143 is 11 13 times 143 and 13 1 times 13. Now write down the factors of 77 starting from the factor 11. The 77 has got a factor of 11. Now look for the 11 in the factors of other numbers. We don't have got any factor of 11 in factors of 91. So in column of 11 in factors of 91, because we don't have got 11 as a factor of 91, so write 11 power 0 instead of leaving an empty space over here. Similarly, look in the factors of 143 for 11, because I am completing the column of 11. We have got 111, so in factors of 43 write 11 in column of 11. Now go back to 77. We have got another factor 7 in factors of 77, so enter 7 in factor of 77. Now look for 7 in the factors of 91. Yes, we have got a 7 in factor of 91, so enter 7 in factor of 91 in the column of 7. Now look for 7 in the factors of 143. We don't got 7 in factors of 143, so enter 7 power 0 in column of 7 in line of 143, factors of 143, because instead of leaving an empty space we have to enter 7 power 0, because 7 power 0 is 1. It will not affect the result of the question. So enter 7 power 0 in order to complete the column. Now in factor of 77 you don't have got any more. So in factors 91 we have got 13. So in factors of 91 enter 13. In factor of 77 we don't have a 13. So in factors of 77 you have to enter 13 but with power 0, because it was absent. We don't have a 13 in factor of 77. In factor of 143 we have got a 13. So in factor of 143 enter 13. So we have completed column of 11, 7 and 13. No, because we have to find HCF. From each column you have to take out the number with the least power. So from column of 11, 11 power 0 is the least one. From column of 7, 7 power 0 is the least one. And from column of 13, 13 power 0 is the least one. Each power 0, any number power 0 is 1, 11 power 0 is 1, 7 power 0 is 1, 13 power 0 is 1. So 1 into 1 into 1 will give you HCF as 1. Now exercise 1b, D1 7th edition. This is question number 2, and we have to find lowest common multiple of each of the following sets of numbers. So here we have got question number 2 to find LCM of 24 and 30. 2 prime factorization of 24, to 12 times 24, to 6 times 12, to 3 times 6, 3 1 times 3. Do prime factorization of 30, to 15 times 30, 3 5 times 15, 5 1 times 5. Now write down the factors of 24 and 30 in index notation. So from 24 pick first of all 2. 2 2 2 becomes 2 cube. Now look for the same factor in factors of 30, mean for 2. Yes, we have got 1 2 in factors of 30. So write down this 2 in the line of 30. So we have completed the column of 2. Now go back to 24 and look for the next factor, which is 3. So in factors of 24, write down 3 as its next factor. Then go in the factors of 30 and look for the same number, that is 3 over here in factors of 30. Yes, we have got a 3 in factors of 30. Now write down this 3 in factors of 30, but it should be under the 3 like over here. So this becomes complete column of 3. Now the next factor which is present in 30, mean 5 is a factor of 30. So I have written 5 in the factors of 30, but this 5 is not a factor of 24. So in factors of 24, because 5 is not present in factors of 24, instead of leaving an empty space over here, enter 5 but with power 0. So if any factor is missing, you can enter it with 5 power 0, mean with power 0. Now I have completed all the columns of 2, 3 and 5. Now because we are talking about LCM, from each column, take out the highest power of each number. Now from these two, I am going to take out the highest power, mean 2 power 3, because I am talking about LCM. Similarly, from the column of 3, when powers are equal, we will take the same power, mean 3 power 1 will be taken out. And from these two 5s, we have to take out the power which is the large one. So 5 power 1 will be taken out. So this is LCM. That's why I am taking out the highest power from each column. So 2 power 3 is 8, 3 power 1 is 3, 5 power 1 is 5, 8 into 3 24 and 24 into 5 is 120, the LCM for this part. In part B, you have to find the LCM of 42 and 462. The 42 prime factorization is 221 times 42, 3 7 times 21, 7 1 times 7. While prime factorization of 462 is 2 231 times 462, 377 times 231, 7 11 times 77, 11 1 time 11. Now write down the factors of 42 and 462 and do it stepwise. First of all, starting from 2, 2 is a factor of 42, so 2 is written in factors of 42. 2 is also a factor of 462, so in factors of 462, write 2 in the column of 2. The first column of 2 is complete. Move to the next factor of 42, which is 3. So 3 is written in factors of 42. Now look for 3 in factor of 462. Yes, we have got a 3 in factor of 462. Write down 3 in factor of 462. Now the next factor of 42 is 7. Write down 7 in factors of 42. Now look for 7 in factor of 462. Yes, we have got a 7 in factor of 462. Write down this 7 here in factor of 462 in column of 7. Now we don't have any other factor of 42 over here, but in 462 we have got 11 as factor of 462. Enter 11 in factors of 462. 11 is not a factor of 42, so in factors of 42 enter 11 power 0 because it is not a factor of 42, so you can enter it as 11 power 0 in order to complete the column of 11. Now from each column, take out the number with highest power. From column of 2, I will take out 2 power 1. From column of 3, 3 power 1 will be taken out. From column of 7, 7 power 1 will be taken out. And from column of 11, 11 power 1, which is greater than the 11 power 0, is taken out. And multiplying all these numbers, you will get 462 as an LCM of 42 and 462. In part C, you have to find the LCM of 12, 18 and 81. So write down do prime factorization of 12, 18 and 81. Prime factorization of 12 is 2 6 times 12, 2 3 times 6, 3 1 times 3. Prime factorization of 18 is 2 9 times 18, 3 3 times 9, 3 1 times 3. and prime factorization of here 81 is 3, 27 times 81, 3 9 times 27, 3 3 times 9, 3 1 times 3. Now express each 12, 18 and 81 as product of its prime factors in index notation. Starting from 12 and starting from 2. We have got 2 and 2 in factors of 12. So in index notation, this will be written as 2 square. Now look for the factor 2 in factors of 18. We have got a 2 in factor of 18. So write down this 2 in factors of 18 in column of 2. Now look for the factor 2 in factor of 81. We don't have got any 2. So in factors of 81 in column of 2, enter 2 but with power 0 because we don't have a factor 2 in factors of 81. Move to the next factor of 12, which is 3. Enter 3 in factor of 12. Then move to 18. Look for the factor 3 in factor of 18. We have got 2 3's. Write it as 3 square in factor of 18 in column of 3. Look for the factor 3 in factors of 81. We have got 4 3's. Write it as 3 power 4 in factor of 81 in column of 3. From column of 2, take out maximum power of 2. From column of 3, take out maximum power of 3 because in LCM we have to take out maximum powers. 2 square is 4, 3 power 4 is 81, 81 into 4 is 324. In the last part of question number 2, exercise 1b, D1, 7th addition, we have to find LCM of 63, 80 and 102. So LCM of 63 is 320, factorization of 63 is 321 times 63, 37 times 21, 71 times 7. Similarly, do prime factorization of 80 as well as of 102. Now write down the factors of 63, 60 and starting from 3. So 63 have got 2 3's. So 3 and 3 becomes 3 square. So write 3 square in factor of 63. Now look for the same factors 3 in factors of 80. We don't have got any 3 in factors of 80. So in line of the factors of 80, write down 3 in the column of 3 but with power 0. So 3 power 0 will be written over here instead of leaving it empty because 80 don't have got any factor 3. Now look for the factor 3 in factors of 102. You have got 3, enter 3 in factor of 102 in the column of 3. The column of the factors 3 is complete. Now move to the next factor of 63, which is 7. So 7 is entered here in factor of 63. Look for 7 in factors of 80. We don't have any factor of 7 in factors of 80. So enter 7 power 0 over here. Any missing factor is written as power 0. Look for 7 in factor of 102. We don't have got any factor of 7 in factor of 102. Enter it in factor of 102 as 7 power 0 in order to complete the column of 7. Now the next one, in factor of 63, I have entered 3 as well as 7. Now this factor of 2, which is a factor in 80 as well as in 102 but not a factor in 63. Now I am going to enter these one. Now we have got how many 2's in factor of 80? You have got 1, 2, 3, 4. So 2 power 4 is written in factors of 80. Similarly, we have got 1, 2 in factors of 102. So 2 power 1 is written in factor of 102. This 2 power 0 is entered in factor of 63. The reason is that 63 don't have a factor 2. So instead of leaving it empty, enter 2 power 0 over here. Then there is a factor 5, which is not a factor of 63 and not a factor of 102, but it is a factor of 80. So enter 5 in the factors of 80, and because 5 is not a factor in 63, so enter it with 5 power 0 in factor of 63. Similarly, 5 power 0 will be written in factor of 102 because 5 is not a factor of 102, and to complete this column we have entered 5 power 0. Now 17 is a factor of 102 written in the factor of 102, while 17 power 0 is written in the factor of 80 as well as in 63, because you will not find 17 in factor of 80 and in factor of 63. Now you can find LCM by choosing the highest power from each column. Choose highest power from column of 3, 3 power 2. Choose highest power from column of 7, 7 power 1. Choose highest power from column of 2, 2 power 4. Choose highest power from column of 5, 5 power 1, and choose highest power from column of 17, that is 17 power 1, and multiply all of them. You will get 85680 as LCM of 63, 80 and 102. So in the next video I will be uploading intermediate level from exercise 1B. So keep watching and subscribe the channel to get more videos on the solutions of D1. Thank you so much.